If protocols number 1 summarize the different cloning approaches and focus on pipe cloning, in these new protocols I would like to share with you some details regarding priming design for standard restriction ligation cloning approach that is still one of the most used. So each primer should contain 3 different regions. The annealing region, the restriction site, flanked from some specific bases for each enzyme that are important to enhance the enzyme efficiency. So first of all you have to choose your vector, check which restriction enzyme are present at the multicloning site, and choose the restriction enzyme couple that you want to use. So to choose the restriction enzyme you have to think about 3 main points. First of all, which protein form do you like to express? As for example, do you like to express a tagged protein or untagged protein? You would like to insert a protease reconjunction site in your tagged protein or not? Because how you can see in this slide, if you select different restriction enzyme in the same plasmid, you can produce different protein form. You have also to check if the sequence of the restriction enzyme that you chose are present in your DNA sequence, because in this case you have to change restriction enzyme. You cannot use a restriction enzyme that is able to specifically cut your sequence, because in this case you will obtain an unattended DNA digestion of your fragment, so you will not be able to clone the entire fragment into the plasmid, but just a small part of it. Before choose the restriction enzyme, you have also to check if these restriction enzymes are compatible for double digestion. Because if these enzymes are not compatible, you have to do sequential digestion that is time expensive, long and boring. And fortunately, this was a big issue until some years ago, while recently the company SNAB Thermo Fisher developed a new universal buffer where we can perform double digestion with the most of the enzymes. So, once you decided which are the restriction enzymes, you can design the primer. But you have to pay attention to the risk of frame shift. For example, there are some restriction enzymes as NCO that contain inside an ATG sequence which can act as methionine starting codon. In some cases, as for example in the NCO, this methionine starting codon is followed from 1 or 2 other bases. And in these cases, if you just link the restriction site sequence with the annealing sequence, you have a high probability to obtain a frame shift. So you need to find some solution as was done in the 2 examples reported in the presentation. So thank you everyone for the attention, and in the next presentation I will explain to you primer design for pipe cloning, that of course is my preferred cloning approach because it's more suitable for high throughput cloning. Ciao a tutti, grazie, thank you very much, bye.